Aldehydes and ketones have what we call carbonyl groups, which consist of carbon atoms doubly bonded to oxygen atoms. Due to the higher electronegativity of oxygen, the bonding electrons stay closer to it, giving it a partial negative charge. The carbon atom, on the other hand, becomes electron deficient, making them partially positive. The positive charge in the carbon atom makes it susceptible to reactions with nucleophiles, or chemical species with electron pairs that can be donated for bonding with positive centers. Now when this happens, one of the carbon-oxygen bonds goes up and becomes a lone pair on the oxygen atom. The resulting structure would look like this, with the oxygen atom on top having a formal charge of -1. In the presence of acids or water, the oxygen atom forms a bond with hydrogen cations. This mechanism is called nucleophilic addition. Aldehydes and ketones react in this manner because of the way the charges are laid out in their structure. Let us have a look at how this reaction mechanism happens with various nucleophiles. First, let's try using water as a nucleophile. Water molecules have lone pairs in their oxygen atoms, which can be used to bond with a carbonyl carbon like this, accompanied by the movement of one of the carbon-oxygen bonds to the oxygen atom as a lone pair. Checking formal charges, we see that this oxygen atom above has a negative charge, and that the oxygen atom below has a positive charge. Lastly, one of the lone pairs of the negatively charged oxygen atom takes the hydrogen atom below, which leaves its electrons behind, giving us our final product, a geminal diol. Now with an alcohol molecule. Like water, alcohols have lone pairs in their oxygen atoms, which bond with the carbonyl carbon atom similarly, like this. Again, one of the carbon-oxygen bonds go up to become a lone pair. When bonds form and break, it is wise to check the formal charges, like for instance, the charge of the oxygen atom above is now negative, and the oxygen atom below is now positive. Then again, the negatively charged oxygen atom bonds with the hydrogen atom below, with the hydrogen atom leaving its electrons behind. Our final product is called a hemiacetal. If our reactant was a ketone, we would have formed a hemiketal instead. One of the interesting reactions with this mechanism is the reaction of Grignard reagents with aldehydes and ketones. Grignard reagents, which have alkyl groups bonded to magnesium atoms, make their alkyl groups develop strong partial negative charges on the carbon atoms adjacent to their magnesium atoms. Because of this, the carbon-magnesium bond behaves like an electron pair available for bonding. Then again, this carbon-oxygen bond moves up, giving us this structure, followed by the bonding of the oxygen atom with the hydrogen cation, giving us this product.